No? Jacob? I think that the thing that hits the most, well, not the most, but I definitely something that I don't use is I'm used to have my coffee and to drink coffee when I'm teaching, and I hate not being able to do that, and I have this craving of having more coffee. I love coffee. Yeah, so that's something that I like. Oh crap. Okay, we just wait a couple more minutes. Then this is the last thing that we saw. So it's kind of weird because there's like a 2-second delay between anything that I do here and what you guys are gonna see on the screen. So this is always kind of weird. Samantha. No? No. Were you able to finish the quiz? Cool. Okay, so we're gonna be keep talking about vectors. The thing that we were trying to do last class was given the components of a vector. So knowing what is the x and the y components of the vector, how do we calculate the magnitude and how do we calculate the direction of that vector? Okay, that's what the last thing that we do. So now what we're gonna try to do is the opposite. Given a vector, given its magnitude and its direction, how do we calculate the components of the vector? How do we calculate the x and y components of the vector? Okay. So, I'm going to assume that I have, again, my coordinate plane. I have my x and y components. And now what I'm going to have is just the magnitude of the vector. And I'm going to say that this is my vector A. And I want to calculate, and I'm going to say that this vector has a magnitude of 20. And, oops. Sorry. Okay, it has a magnitude of 20, and I'm going to say that the angle here, I'm going to say is an angle of 50 degrees. Okay, so what I want to do is to calculate what is the x component of that vector, and I want to calculate what is the y component of this vector. One of the things that we're going to do with vectors is to do these arithmetic operations. We're going to add them, subtract them, multiply, and etc. And in order to multiply and add and subtract vectors, we need to decompose the vector. We need to know what are the components of the vectors. We cannot add magnitudes and directions. So that's why we need to learn how to do this. Okay, so we need to find out what is the x component, and we need to find out what is the y component. Okay, and it's just basically based on the triangle rectangle. It's just basic trigonometry. So if we look at this vector and it makes a triangle rectangle with the x-axis, so this is 50 degrees, and then the magnitude is equivalent of the hypotenuse. So this is a magnitude of 20 units, whatever units we're working. So then it's okay, how do I calculate the y component? How do I calculate the x component? So there are different options that you can do. You can do sine of theta. I know that sine of theta is going to be opposite over hypotenuse. In this case, the opposite of this angle is the y component. And the hypotenuse is the magnitude of my vector. So that's going to be 20. So in this case, sine of 50 is delta y over 20. And solving for the y component of A is going to be 20 sine of 50. Okay, and from here I can just calculate really quick. And I get 15.3. Okay, for the x component, I can use cosine. So I know that cosine of theta is adjacent over hypotenuse. That will be the x component over 20. So cosine of 50 is the x component over 20. So delta x is 20 cosine of 50. So this is 20. So this is 12.86. Okay. And that's it. Okay, makes sense? It's pretty straightforward. It's just try to remember a little bit of trigonometry. Again, one of the tricky parts of this is try to understand where the components of your vectors are, where they're supposed to be, and don't trust your calculator completely, at least not blindly. Okay, so I want you to do one problem on your own. So we're gonna have something like this. We have the x component, the y component. Now we have a vector. We're gonna say that this is 10 degrees and the magnitude of the vector is 50. And I'm gonna call this vector B. Okay, so same thing, try to calculate what is the x component of B and what is the y component of B. Samantha? Hello.
Yeah, I'm looking up the first week of this.
Say that again? No. I'm just. Don't worry. I'm just trying to figure out who's missing. Okay, so we're gonna try to solve this really quick. Oh, who needs more time? Everybody is done? Or whoever is not done is because they're stuck? Okay, so I'm gonna try to solve this really quick. So again, the easiest way is to imagine that you have a triangle rectangle. So it's gonna look like this. You have a 10-degree angle here, and the magnitude is going to be 50. So again, we are working with this angle. So this is going to be the opposite. This is going to be my y component, and the adjacent is going to be the x component. Okay. So sine of 10 degrees is opposite over hypotenuse. This is going to be the y component over 50. And then the y component is going to be 50 for sine of 10. Jacob, what you got? 8.68. 8.68. 168. I can do something similar for cosine. So cosine of 10 is going to be adjacent over hypotenuse. Cosine of 10, the adjacent I know that is going to be bx. And this will be hypotenuse. And then bx will be 50 cosine of 10. And Paige, what you got?
I did not get that hard, but hold on.
Trinity?
I got 49.2.
49.24, something like that. Okay. So that's what the calculator is telling you that is the answer. And it's correct. What you put in the calculator is those values. I mean, and it's fine. Now, notice that the x component on this vector is to the left of the origin. So this value over here has to be negative. So this bx component, because it's pointing to the left, has to be negative. So the x component is going to be negative 49.24. And the y component is going to be 8.68. Okay. So you have to be careful. And the best way is to draw the vector, look where it is, in what quadrant is placed, and then you can find out, okay, are the x components supposed to be negative? Is the y component supposed to be positive? Or are both supposed to be negative? And then you can figure out, okay, what is the correct signs? Okay. Another option that you can try to do is that, okay, this is 10 degrees. So if this is 10 degrees, it means that this angle, this big angle over here, is 170. And then you can use that angle, but then it's a little more complicated. It's easier because then you're not working with a triangle rectangle. You are working with a really weird triangle. So it's easier to work with triangle rectangles. If you want to work with this, you will need the cosine law, which is a little more complicated. So it's easier just to remember the triangle rectangle and then just adapt the sign that you need to work with. Like, bless you.
Thank you.
Okay, any questions so far? Okay. Now, one of the reasons that we need to have this decomposition of vectors is that we need to do basic operation with vectors. We need to be able to sum vector A plus vector C. That's going to give me a vector. Vector A plus B is going to give me a vector C. And I need to be able to do operations like this. Okay, those are the basic operations. Now, the problem with these kind of operations is that if you have vector A to be 20 degrees magnitude at an angle of 50 degrees and vector B to be 50 degrees at an angle of 10 degrees, if you have something like that, you cannot add them. You cannot do, oh, well, this is going to be 70 at an angle of 60. That's completely wrong. You cannot add vectors like that. The only way you can make operations with vectors is by adding the individual components. So if you want to do A plus B, then you need to add the X component plus the X component of each vector, and then the Y component of each vector. So in order to do any operations with vectors, you need to decompose them, add the component, and then you can calculate the magnitude of the resultant vector. Okay? So we can try to do these two vectors over here. So I have two vectors, X and Y. And the first vector has a magnitude of 20 at 50 degrees. So it's going to be something like this. And the second vector, oh, I need more colors. It's going to be 50 at an angle of 10. So I'm going to say there's something like this. So this is 50 at an angle of 10. So I need to be able to solve those, to add those two vectors. So the way I'm going to do it is, okay, I'm going to try to calculate what are the X and Y components of A. This is going to be A, this is going to be B. And I'm going to try to calculate what are the Y components of A and B. Okay, so we're going to try to do that. So these first two rows, you guys find the components of A, and you, these two rows, try to find the components of B. And Mallory and Dylan, if you have any questions or anything, just write it down on the chat, and I'm keeping an eye on it. Okay, Alexander, what you got for AX?
For AX, I got 15.32.
Yep, 15.32. And for Y?
12.86.
12.86. And Ian, what you got for B?
I got for BF, yeah, 49.24. And for BY, 8.
Okay, so now that we have the components, we have the X and Y components of each of the vectors, then we add the X components with the X components, and we add the Y components with the B components. So the C vector, the resultant vector, again, is going to have X and Y components. And that's going to be the sum of, for the X component, is going to be 49.24 times 15. Plus 49.24 plus 15.32. So that will be 64.56. And then for the Y component, it will be 12.86 plus, so this will be 21.54. Okay, so those are the components of C. Now we need to find the magnitude and direction of C. So the magnitude of C will be 64.56 square plus 21.54 square. This is 68.06. You want to be to the second decimal. And then the angle will be the arctangent of CY over CX. And you get an angle of 18 degrees. So the resultant vector is going to be a little bit bigger than my two original vectors, and it's going to be somewhere in between. So it's going to be somewhere around here. So the C vector is going to be somewhere around there. So if you are subtracting two vectors, it's exactly the same procedure. You just need to change the addition for subtraction, but it's pretty much exactly the same thing. Multiplication by scalar, like if you have a scalar A times a vector A, oops, you have something like that, then this will be the same as multiplying each of these components by a scalar. When you multiply by a scalar, you change the magnitude of the vector, but the direction doesn't change. Okay, so if you have a vector and you multiply by a fact for any factor for a factor of 2, then you just make a vector that is twice as long, but it's pointing in the same direction. Okay. There's also multiplication and division of vectors, but it actually requires a little bit more math that we are not gonna go over it. But there's such thing as multiplication, and actually there are two kinds of multiplication with vectors, and there's also division of vectors, which is a little more complicated. So for this class, the only thing that we care is addition, subtraction, and multiplication by scalars. Okay, those are the only three operations that we're gonna be needing. Okay, make sense? Samantha, make sense? Okay, so we're gonna try what I'm gonna let you guys do. Okay, so this is vector A, and this is going to be vector B. Okay, so I'm going to assume that vector A has a magnitude of 30 units and is 20 degrees below the x-axis. So this angle over here represents this angle over here, represents this theta A. And vector V has a magnitude of 40 units and is 35 degrees below the negative x-axis. So this is going to be 35 degrees. So this is 35, and this is 20. Okay, and what I want to do is just A plus B. I want to know what is just an addition of the vectors.
Yeah, I mean, I don't mind.
Do you run with it?
I think it's 6 months.
Okay.
But wait, yeah.
Yes. Yeah.
So is that a special iPad? What
No, it's just some street like that.
is
Yeah, it's not.
the one that?
Yeah, and then I've seen now, you can also use like Microsoft, like the other one. So it's the one. Yeah.
So again, just be careful with the signs. Uh, okay. So again, the way you solve these problems is just assume that you have a triangle, rectangle. For each one of them, you have your angle, in this case, I have the opposite and I have the adjacent. And then using trigonometric functions, you can calculate where are the components. Again, because in the case of vector A is in the fourth quadrant. So four quadrants have positive x's and they have a negative y. So I need to have a positive x and I have a negative y. For vector B, this one is on the third quadrant, and third quadrants they have negative x's and negative y's. So I need to have a negative x and a negative y. Okay. If I want to add these two vectors, I will add my vector vector C. So, ouch. I will have minus 4.56, and this one will be, oops. Minus 32.2. Okay. I can calculate the magnitude of C. Oops. It will be 33.51, and the angle of C That will be 81.94. So if you look at the components, I have a very small x, minus 4.6. So my x is going to be somewhere around here, and a very large y. So the y is going to be all the way down here. So my vector is going to be somewhere around here. So this 81 degrees is going to be this one. This one is delta C. Okay, you can express this vector, the direction in different ways, and that's what makes the direction a little bit complicated. I can say that the directions to be this angle instead, and say, well, this is going to be 8 degrees, 8 something. Or I can say that the angle is going to be 81 degrees. Or I can do the whole almost 270 degrees, 262 degrees. So you can do different ways, and you can also do it like that. So that's what it makes a little bit complicated. You are free to use any configuration that you want. I usually tend to use reference the x-axis, and that makes me a little bit consistent. And then I just try to express if it's the vector is in the first quadrant or the second quadrant, the third quadrant, and so on. Okay. Sometimes you will need to change the reference, the axis of reference. But if you keep the x-axis as a reference, that's going to be less confusing for everybody. Okay. Make sense? Any questions? Okay. Oops. Okay, so we're gonna stop a little bit with the calculations right now, and that's it. That's chapter 3. If you the rest of chapter 3 talks a lot about velocities, circular motion, and relative velocities and stuff like that. We're not gonna deal with velocities and motion right now. Actually, we're gonna be dealing with velocities, accelerations, and all that stuff. That's gonna be almost at the end of the semester. We're gonna skip to chapter 4 and 5, and we're gonna continue to force 5. And then 8. That's more or less the sequence that we're gonna be following. So chapter 4, 5, and 8, which is basically deals with forces. And with forces, one of the things that we care the most is equilibrium. How do we know that something's equilibrium? And especially how the human body is affected by different forces. So what is the effect of forces on bones? And what is the effect of forces in the sense of equilibrium and torques, something that they call like that. And so that's basically what we're going to be spending some time in the next 2 to 3 weeks. That's going to be a big chunk. Pretty much your first partial, your first midterm is going to be chapters 3, 4, 5, and 8. Okay, or at least that's my hope. Can someone tell me what you guys understand by forces? Paige?
Yeah, not coming to me.
Alexis? Alexis?
Yeah.
Yeah. What your first gut of a force? What do you think of a force?
I guess it's something applied to something.
Something applied to something. Actually, yeah, that's one of the definitions of forces. It's an action that something applies into something else. You need to have an object that the force is going to be applied to, and that force has to be applied by something else. You don't have forces just appearing out of nowhere. There has to be a source of the force, and there has to be an object in which that force is going to be aimed to. So actually, yeah, that's good. Anyone else? Over.
I mean, it's going to matter with vectors, like the direction and the magnitude of the force, and if there's opposing forces.
Force is a vector. So there you go. We have 3 things already. You need to apply a force to something, that force has to be applied by something else, and the force is a vector. So we already have three things. Noah?
Newton's three laws is what I was.
Oh no, you are way advanced. No. Slow down. No, we're not talking about Newtons and all this stuff later. Something else? Ian? What kind of forces? What can a force do? It moves objects. The source of motion is a force. If something is moving or something is stopping, and by moving it can be slowing down or speeding up, is because there's a force. Noah? Forces resist motion, or motion resists the force, yeah. So a couple of things. The kind of forces that we usually deal with are always going to be either a push or a pull, always. So if something is pushing you, if something is pulling you, it's because of force. The force have to be applied to an object, and something has to apply an object. So you always have two things. One thing that is receiving the force, and one thing that is doing the force. Force is a vector. And the one that is not very obvious is that forces can be contact forces, which are the ones that we tend to think the most, like you pushing someone or something pushing you, or being pulled by a rope or something like that. So those are contact forces. And the other one are forces that can be, they're called long-range forces, in which the objects don't have to be in contact. And the most common case is, I'm going to have to do it in the camera, is gravity. So gravity is a force that the Earth exerts on the pen and the pen on the Earth, but they're not in touch with each other. However, we feel that force. It's falling down. Another force that doesn't have to be in contact is magnets. So if you have two magnets, they don't have to be in contact, and then you see that one's pulling the other, or well, both are pulling each other. So those are forces that they don't have to be in contact, but they exist. Okay. There are other forces that are non-contact forces or long-range forces, but the two main ones that we're going to be dealing is one is gravity, and the other one is going to be magnetism or magnets. But that's going to be way later. There are different kind of forces. There are different kind of forces. Give me a minute here. And some of them you have used them before. So the one that's more common for everybody is weight. Okay, weight is a specific kind of force, and the weight is the force caused by gravity in our case by Earth on a mass, on an object. Okay, that's a very common kind of force, and we're gonna be using weights a lot. The other one is spring forces. And a spring is caused by compression or tension of an elastic material. So when we think about springs, we tend to think about this kind of metallic coil that you can compress, and then you can extend, and when you release the force, it's going to go back to its position. But springs are not only that. Like, for example, the tendons in your body, they are some kind of springs. They are materials that you can extend and you can compress, and when you release the force, they come back to its natural shape. So tendons are kind of springs, or they can be modeled with the same equations that we use to describe something like this. Your skin is also a kind of spring. Like if you pull your skin, it goes back to its natural shape. So it can model to a point for a spring of muscles and also these springs. So it's just compression or tension of elastic materials. It can be organic or inorganic materials. Okay, tension. Tension is kind of weird. This is always going to be a pull force. It's always going to pull you, and it's caused by a string or a rope. You cannot push with a rope. You can only pull. So we call tension. It's a specific kind of force just because it only has a pull action, and there's no way you can have you cannot push with a rope. Okay. There's something that's called the normal force. And normal force, we're gonna spend some time talking about this later. Normal here is a mathematical term, which means perpendicular. And the normal force basically says, okay, if I have a surface, and a surface doesn't have to be flat, it can be a tilted surface, and I have an object on that surface, I'm always going to have a normal force caused by the object to the surface. And the normal force is going to be perpendicular to the surface. So in this case, the normal force is going to go like this. In the second case, the normal force is going to go like this. If I had a wall and I have a book pushing on a book, then I'm going to have a normal force like this. If you can imagine a roller coaster, oops, and you are in that loop in a roller coaster, and you are there, then you're going to have a normal force like that. Okay, so normal forces are always perpendicular to the surface. Okay, and it always going to appear when you have an object in contact with the surface. At the moment that that object is not in contact, the normal force disappears. Okay. Now, the one that we are more familiar is friction. Samantha, what do you think is friction? Yeah, it's two surfaces that one is sliding with respect of the other, and that sliding is not smooth. The sliding is going to slow down one of the objects, and that's basically friction. So friction always opposes motion. And it's going to happen between two objects. Well, always opposing motion. I'm going to leave it like that. Okay. There are two kinds of frictions, but we're going to be talking about those a little more in detail. Then it's drag. And drag is very similar to friction. The difference is that drag it happens when an object moves inside a fluid. We tend to think of fluids like liquids, but gases are also fluids. Like, so when a car is moving through the highway, as the velocity of the car increases, the air around it is going to displace, and there's going to be some drag. If you are moving inside a water, you try to run in water, you feel the drag. If you are in one of those pools with a lot of balls, and you try to run on those things, and the balls prevent your motion, that's drag, even though they're solids. Those balls can be represented as fluids. So fluids, it's just a big umbrella term. It doesn't necessarily have to be a liquid, can be gases. In some cases, if you have sand or granular masses, they can also be that. So that's drag. And it's just different from friction because friction is always along the surface of the object. And the last one is thrust. That's just basically rockets and airplanes and things that are pushing through a liquid, through a fluid. Okay. Any question? Okay, so couple of things. We're going to stop soon. I'm trying to keep the two sections more or less at the same pace. So that means that sometimes I'm going to keep you guys a little bit later and I let them go out earlier or vice versa. So in this case, you are unlocked. You get to get out earlier. A couple of things. There's a quiz due on Monday. The quiz is about forces. So you will need to read chapter 4. What we saw right now, I think it's pretty much all chapter 4, or at least it's half of chapter 4. The rest of the chapter 4 goes into specifics of the different kind of forces. But we start chapter 4 and 5 next week, and that's it. Any questions? No? Okay. Have a good weekend, and see you guys on Monday.
I was just curious if I could set up a time with you.
Sure.
Get some thoughts on the time.
Sure.
Last time I used it was for your geometry.
Okay.
I only took it for physics in high school. So
Yeah. We can go through that.
I have a meeting at 9:35, but
I'm available today at 1.
okay. I have a class from 12.
That's after
Okay.
1.
Okay, yeah,
Okay.
just come to your office.
Yep.
Okay. Thank you.
You're welcome.